Right now, on your land, an animal is eating. You never bought it. You never fed it on purpose. You never built it a pen or filled a trough. And yet every single day, it is converting your losses into pure protein, and almost none of that protein ever ends up in your hands. Most people look at a small farm and count what they paid for: the chickens, the goats, the bag of feed that gets lighter and more expensive every single month. They see the animals they own as the engine, and the feed bill as the price of keeping that engine running. It feels like the natural order of things. You buy inputs, the animals eat them, and you sell what comes out the other side. But the most efficient farms on Earth don't think in animals, they think in flows, and they noticed something you walk past every single morning without seeing it. Think about what leaves your kitchen this week: the peelings, the spoiled fruit, the plate scrapings nobody finished. Now add the losses from the land itself: the split tomatoes, the bolted greens, the manure under your chickens and rabbits. On most farms, all of it goes one of three places. It rots in a heap, it gets hauled away, or it sits in a bin and starts to stink. You think of it as waste, as the unavoidable cost of producing food. It is not waste, it is feed, and something is already eating it. Walk out to that rotting pile on a warm afternoon and look closely. The flies you see are not random. Many of them are doing a job. Their offspring are devouring that organic matter and turning it into dense, fast-growing bodies. You are running a feed operation right now. You just aren't collecting the product. Here is the question almost nobody on a small farm asks: what if the most valuable animal on your acre is the one you've been trying to get rid of? The animal in question is the black soldier fly. And before you flinch at the word fly, understand that this is not the housefly buzzing around your kitchen. The adult black soldier fly has no working mouthparts. It does not bite. It does not feed. It does not spread disease because it cannot eat your food or land on your wounds. The adult lives for about a week, mates, lays eggs and dies. Everything that matters happens before that, in the larval stage, when it is one of the most efficient waste-to-protein converters ever measured. A single female lays somewhere around 500 to 900 eggs in her short life. Those eggs hatch into larvae, and the larvae do one thing with terrifying focus: they eat. They eat your scraps, your spoiled produce, your manure, your losses, and as they eat, they grow into plump, pale grubs packed with protein and fat. How packed? Dried black soldier fly larvae run roughly 40 to 45% protein and around 30% fat. That is not a homestead rumor. That is the figure that shows up again and again in the research. Compare that to the commercial feed you're buying by the sack, and you start to understand what you've been throwing on the compost heap. The man who first proved this could be a farm system rather than a laboratory curiosity was Dr. Craig Shepard at the University of Georgia. Back in the early days of this work, Shepard was studying manure management at poultry and swine operations, looking for a way to deal with the waste. What he documented was that black soldier fly larvae didn't just reduce the manure, they consumed a large share of it, suppressed the houseflies that breed in it, and produced a harvestable crop of larvae, rich enough to feed back to the very animals that made the waste. He had stumbled onto a loop. Sit with that for a second. The waste from your animals becomes feed for an insect, and that insect becomes feed for your animals. Nothing leaves, nothing gets bought. The loop closes on itself. Why does this work so well? Part of the answer comes from researchers like Dr. Stephan Diener, who studied how efficiently these larvae convert organic waste into body mass. The larvae are voracious. They tolerate a wide range of messy, wet, real-world waste, and they reduce the volume of that waste dramatically as they feed. A heaping bin of scraps and manure shrinks down, and a portion of what disappears walks back out as larvae you can collect. They also generate heat and movement that drives away the slower, dirtier houseflies, which is why a working colony actually smells less foul than the rotting pile you started with. And then there is the part that makes this practical instead of just clever. The larvae harvest themselves. When a black soldier fly larva is mature and ready to pupate, its instinct is to crawl up and out of the wet feed, looking for somewhere dry to finish its transformation. It climbs. If you give it a ramp, an angled edge it can climb, it follows that ramp up and over the lip and drops straight into a bucket you've placed at the end. You don't sort them. You don't dig through manure with your hands. You don't separate the living from the rotting. They sort themselves by the thousand and deliver themselves into your container while you sleep. That is what self-harvest means. The animal does the labor of its own collection. So picture the simplest possible version of this on your land: a container, partly shaded, kept moist. You feed it your kitchen scraps, your bruised produce, your animal manure, the stuff you were already going to dispose of. The larvae move in, often on their own, drawn by the smell. They process the waste down to a fraction of its volume. The mature ones climb the ramp and drop into your bucket. Every morning you walk out, and there's a fresh scoop of live, protein-rich feed waiting for you, paid for entirely by garbage. Now, what do you do with that bucket? This is where the loop pays you. Those larvae are very close to a natural diet for several animals you may already keep. Chickens go after them like candy, and the larvae deliver the protein that drives egg production. Quail thrive on them, and if there's a pond or a tank anywhere in your system, fish like tilapia treat black soldier fly larvae as a primary feed. The waste that used to cost you money to remove is now offsetting the feed you used to buy. That is the entire move. You captured an animal that was already feeding for free, and you pointed its output back into your farm. The scale of what's being recovered here is not trivial, and serious institutions have said so plainly. In 2013, the Food and Agriculture Organization of the United Nations, in the landmark report led by Dr. Arnold van Hise, named insect farming as a credible answer to the rising cost and environmental strain of conventional animal feed. The black soldier fly sits at the very center of that conversation, precisely because it eats what we discard and produces what we are otherwise paying dearly to grow. The science you're applying on one container in your backyard is the same science being built into industrial facilities right now. But before you go all in, you need to hear the pitfall, because there is one mistake that turns this from an asset into a problem. The mistake is letting the system go anaerobic. Anaerobic means without air. When you pack a bin too deep, too wet, and too tight, the oxygen gets used up, and the contents stop being processed by larvae and start to truly rot. That is the smell you don't want. That is the soup that drives the soldier flies away and invites the exact pests you were trying to avoid. A healthy black soldier fly bin is active, churning, and surprisingly tolerable to stand next to. A neglected one is a stinking pit. The difference is air and drainage. Keep the feed in a layer the larvae can work through, let excess liquid drain away, and don't bury them faster than they can eat. Get that one thing right, and the system runs almost on its own. There's a second, subtler trap, and it's about identity. Make sure you're cultivating the black soldier fly and not just breeding houseflies. The good colony is dominated by those dark, fast-moving larvae and the slim wasp-like adult that doesn't bother you. If your pile is mostly small white maggots and clouds of common houseflies, you don't have a feed system, you have a sanitation problem. The presence of soldier fly larvae actively crowds the houseflies out, which is one of the clearest signs that your loop is working the way Shepard documented decades ago. So let's build the system in plain steps on the land you already have. Start with one bin and your existing waste stream, the scraps and manure you produce every week. Let the local soldier flies find it, which in warm weather they usually will, or seed it with larvae if you want to move faster. Add the ramp and the collection bucket so the harvest comes to you. Then take that first bucket of larvae and feed it to the animals you already keep, and watch your feed bill flinch. That's it. One bin, one ramp, one bucket, one loop. What you've done is quietly change the math of your whole farm. The waste that was a cost is now an input. The animal you were swatting is now a producer. The feed you were hauling in by the sack is now partly walking itself into a bucket each morning. And every other animal on your acre, the chickens, the quail, the fish, gets cheaper to keep because the most expensive thing about them, the feed, is being subsidized by the cheapest thing on your land, your losses. This is the node almost nobody captures, and it's the one that quietly funds everything else. Researchers like Jeffrey Tomberlin at Texas A&M have spent years mapping exactly how this insect behaves, how it processes waste, how it can be reared reliably, because the implications reach far past any single farm. But you don't need a laboratory to run the loop. You need a bin, a ramp, and the willingness to see your waste for what it actually is. So go back to that pile you walk past every morning. Look at it again. It was never garbage. It was a feed bill you'd already paid, sitting uncollected. Right now, on your land, an animal is eating. You never bought it, and starting tomorrow, it works for you.